Good evening, Mohit. Can we go ahead, Mohit? Can we start? Mohit, can we start? Can we start? Can we go ahead? Okay. So let me start now. I think all the people came. All the people came. We can start. All the people came. We can start. Yeah, I'm starting now. I think audio, video, everything fine. So let me go ahead. So yesterday we discussed until here. Yesterday we discussed until here. Let me write the date today. I think yesterday is date 6. I think so. Yesterday date is 6. Today is 7. Let me go to the 7. Seven 8:25. 7/8/25. Today's class is just starting now. Today's class is just starting now. I'm starting. Today's class is just starting now. I'm starting, right? Yeah. Be ready, everyone. Be ready, everyone. Today's class is just starting now. Be ready, everyone. Just give me 1 minute. 1 minute, just give me. Yeah. Fine. Now I'm writing. Now. So before going to the today's class is just starting now. I'm starting now. 1, 2, 3. I'm starting. 7/8/25. 7/8/25. That is the today's date. Right. Now few questions. Those people who attended the yesterday's class. Few questions I'm asking. Who can store data inside symbol table? Please give answer clearly. The people who attended the yesterday's class, please let me know what will store inside, right? I'm asking, who will store inside symbol table? That's the first question. Who will store inside symbol table? That is the first question. What is the answer? Kittu, who will store inside symbol table? What is the answer? Mohit, please give answer. Who will store inside symbol table? Make it fast. Who will store inside symbol table? Mohit, Kittu, Ella, Tarab. All functions of compiler, all can store. Right? All people can store. And one more thing. What will store inside symbol table? Who will store? All people can store. It's okay. But what will store inside? What will store inside? I want that answer also. What will store inside? I want that answer also. Yeah, user-defined things, user-defined variable, user-defined function, identifiers, variable and function, which is nothing but user, right? Simple short name is identifier. Short name is identifier. Identification purpose, we are giving variable name. Identification purpose, we are giving function name. They both are called identifier. Identifiers will store inside symbol table. So you may say that, what about operator? They are already there inside compiler. Compiler means grammar. Grammar means rules. Compiler is nothing but rules. Compiler is nothing but rules. Sir, what about operator? They are already there in the compiler. Compiler means grammar. Grammar means rules. It is one of the rule. In C programming, these operators only allowed. It is one of the rule. In C programming, these keywords only allowed. It is one of the rule. So user-defined variables and functions will be stored. Now some people are asking, user-defined variable functions will store, it's okay. User-defined variable functions will store, it's okay. Now if I go to inside symbol table, user-defined variables are there, functions are there, function there, it's okay. My one more question I want to ask you, along with variable, what will store inside symbol table? Variable name and variable type also. When you are storing variable inside symbol table, what you have to store? Variable name and variable type, and it will store one more column, right? Scope. It will store one more column, scope. Local variable or global variable. What is the scope of a variable? So if you see the first row, you will find out variable name is XO, type is float, next one is scope of a variable. Is it local variable or global variable? And one more, memory location of that particular variable. In the memory where it will store, that memory address also will be there. In the memory where it will store, right? That memory location also will be there. One more column for memory location. What is the variable name? What is the variable type? What is the scope of a variable? Right? Global variable or local variable, local to which function? So everything about that particular variable will be there. And one more thing, when you say it is a variable in the memory for this variable, at which location memory is allocated. So all the things will be there. Suppose if it is a function, everyone listen. If it is a function, what is the function name? What is the function name? And one more thing. That function will take what kind of input? Means what is the input to that function? Next one, what is the return data type? What is the return data type of that function? What are the data types of inputs? Suppose for a particular function, you are passing two parameters, two integers. So int. So input is two integers, int comma int. Output is one float. It is returning float. So output is float. Return data type, input data type. What is the function name? All the information will be there. All the information will be there. Again, I am repeating. In the symbol table, right? If you observe the entries, whichever is coming, all can store. Right? All can store. Next one, what will store inside? Right? Identifiers, variable name and function name. Variable means what it will store? Variable name, variable type, and scope of a variable, and address of that variable where memory is allocated. Now next one, if at all function will store, what will store inside? So function name, that function will take what kind of input, means their data type. Suppose function, it is taking two integers. So input is going to be integer type comma integer type. So finally that function returning a float. So return data type is float. So everything will be there. Okay, whatever you got, it's okay. Can you help me now? Lexical analyzer purpose. Please give answer to me this also. Lexical analyzer purpose. Tokenization. Lexical analyzer purpose is tokenization, dividing program into tokens. Syntax analyzer purpose, creating syntax tree. Syntax analyzer purpose is creating syntax tree. Some people are asking, sir, to create syntax tree, grammar required, na? To create syntax tree, right? I think input string also required. To create syntax tree, input string also required, grammar also required. Both required. If both there, then only you can create the tree. But right, input, right, see this one, string is given by user because it is a user program, but grammar is compiler. You no need to give explicitly, right? You no need to give explicitly. Inside there is a grammar. So that grammar will be taken. The program which you written for that, using the grammar, they will try to draw the tree. If tree possible, syntax tree possible, no syntax error. Syntax tree not possible, there is a syntax error. But anyhow, input is going to be token string, output is going to be syntax tree or parse tree. That will be input to semantic, right? That will be input to semantic analyzer. Semantic analyzer will take the syntax tree as the input, and everywhere it will go inside the tree. It will ask every person, what is your type? What is your type? He bothered. Semantic analyzer bothered about types. Semantic analyzer bothered about types. It is something like, right? It is something like, remember, syntax analyzer will check physically person is okay or not. Syntax analyzer will check physically. Physically means that, right? See, tree came or not. Tree came or not. Physically program correct or not. Syntax analyzer bother about physically program correct or not. Semantic analyzer bother about, right? Not physically, logically program correct or not. Logically program correct or not. There are some doctors who will work on the physical appearance. There are some doctors who will work on the physical, how the person look like physically. So why your hand is like this? What is the problem? Some doctors will work. Why your leg is like this? Why are you walking like that? Why don't you walk properly? So some doctors will work, right? Physically, how person look like. There are some doctors who will work on the physical appearance. There are some doctors who will work on not physical appearance, logical appearance. Means mentally how a person can be. Right? Mentally how a person can be. Right? There are some people who will work on the, right, logically how that person, not physically, logically. There are some people who will work on the mental, right? What is the mental status of a particular person? Right? So I think you know very well. Semantic analyzer is meaning wise program correct or not, mentally program correct or not, logically program correct or not. Next one, physically program correct or not is a syntax analyzer, logically program correct or not syntax, right? Semantic analyzer. What is the meaning of logically? Can you help me now? In the program, what is the meaning of logically? Can anyone help me? Program logically correct or not? Program logically correct or not? Can you say what it means? Program physically correct or not? That is called syntax. Program logically correct or not? Can you say what is that? Can anyone guess? Program logically correct or not? Program physically correct or not? That is called syntax. Logically correct or not? That is called semantic. Can you say some semantic? Logically means semantic. Can you say some semantic? Semantic. Program logically correct or not? Physically means syntax. Logically correct or not? Program logically correct or not? I will give some examples. One logical error is, listen, one logical error is, if you want to perform any operation between two variables, both should be same type. Exactly. One logical thing is, right? If you want to perform any operation between two variables, both should be same type. That is a one logical error. Suppose both are not same type, it is a logical error. If both are not same type, but you are trying to do, that is going to be logical error. So you will try to convert. If conversion is not possible, type mismatch error will come. If conversion is not possible, type mismatch error will come. Can you say one more logical error? Can anyone help me? One more logical error. One logical error is both should be same type. If you want to perform any operation between two variables, both should be same type. That is one logical error, which is also called one semantic error. Can you say one more semantic error? Can everyone try? One more semantic error. One more semantic error. Can anyone guess? Can anyone guess? One more semantic error. Can you guess? Same type or not? That is okay. One more semantic error. One more semantic error. बोलो यार. अरे मोहित बोलो. अरे किट्टू बोलो ना. One semantic error is both will be same type or not. One more semantic error. Arey say something na, right or wrong. How it matter? Right or wrong? How it matter? Say your opinion. One more semantic error. Don't use any variable without declaration. Without declaration, don't use any variable. Without declaration, don't use any variable. That is called undeclared variable. You will get the error message undeclared variable. Without declaration, don't use any variable. If you do that, you will get the undeclared variable. Not out of bound, right? Undeclared variable error message you will get. You cannot use any variable without declaration. First declare, then use it. Suppose if anyone say, sir, I will use without declaration. It is like this. In your house, there is no person, name is Vijay. In your house, there is no person with the name Vijay. But if I keep on saying in your house, Vijay, no one will come. You cannot use Vijay name if Vijay is not there inside house. Inside your house, there is no Vijay. Then how can you use the Vijay? So I went to inside your house. I will say, hello Vijay, come. I went inside your house. I am saying, hello Vijay, come. Hello Vijay, come. Hello Vijay, come. No Vijay. In the house, no Vijay. How can you call? Then one person will come and will say that. You are calling Vijay who is not there in the house. This is called undeclared variable. Error message. You are using some variable which is not declared. Undeclared variable. Undeclared, right? Undefined function. Undeclared variable or undeclared, right, function, something like that. There is one more semantic error. Can anyone help me? There is one more semantic error. Can anyone help me? One semantic error is if you want to do any operation between two variables, both should be same type. One more semantic error is going to be without declaration, you cannot use any variable. One more semantic error. Can anyone help? Semantic means meaning. If person Vijay not there, how can you call Vijay come? Vijay is not there. Declaration not there means he is not there. If he is not there, how can you call Vijay come? So remember, if any person not exist, if you go and keep on calling Vijay come, definitely Vijay will not come. One of the member will come and will inform that Vijay not exist. Undeclared variable. Someone is saying missing return statement. No. One is undeclared variable. Another one is going to be same type, means a type mismatch error. One more thing. Same variable you declared two times. Int A. Same variable you declared two times. Int A. One more time you declared int A. Now two A's are there. If I say A, which will come? Two A's will come. This is called as multiple declaration error. With the same name, two variable you cannot declare. If you declare, you will get the multiple declaration error. Fine. You will get the multiple declaration error. Okay. One is type mismatch. Another one is undeclared variable. Another one is multiple declaration. Same variable you cannot declare twice. If you declare, it will give error message, multiple declaration error. Try to understand. Same variable you cannot declare two times. If you do that, you will get the multiple declaration error. It is something like this. In a house, listen, there are two kids are there. Both the kid you kept the same name. Let us assume that kid 2 married. Let us assume that kid 2 is now around 20 years. Kid 2 is now around 20 years. Let us assume that he married. After 5 years, or maybe after 10 years, he married. So kid 2 married. So, right, and one more, he is going to get kid. He planned in the nice way, right? He is going to get one kid. He is going to get kid. So he and his partner, he and his wife, they both planned that. So kid is coming. So kid name, what we will keep? What we will keep the kid name? They both discussed. They kept like this. If at all boy, we will keep some Y. If at all girl, we will keep Z. So kid 2 and kid 2 partner both are planned, right? So they got to know one kid is going to come. They don't know it's boy or girl, they don't know. So they decided, if at all boy, we will keep the name as Y. If it is girl, we will keep the name as Z. But unfortunately, luckily, by God's grace, kid 2 got twins. Kid 2 got twins. So if boy, they want to keep Y. If girl, they want to keep Z. But unfortunately, at a time, two people came. Twins came. They both are boys. Now, kid 2 don't know what he have to do because he selected boy means Y, girl means Z. So because of two boys came, kid 2 and the kid 2 partner, kid 2 only. Kid 2 finally decided both the boys' name is Y only. Both the boys' name is Y only. So he got twins. Both are boys only. So he kept the name as Y. So there are two kids came. Both the names are Y. Now see what happened. After few days, kid 2 came from office, and kid 2 is saying that hello Y come. But when he said hello Y come, both the kids came saying that papa like that. Both the kids came. Then kid 2 shouted on the elder one, I didn't call you, why you came? Then he also shouted back saying that my name also Y. What I mean to say is directly, if anyone is not getting what I mean to say is, same name if you keep to two people, confusion will come. Kid 2 kept both the kids' name as Y. When he say Y, both are coming. Every time this problem is coming. The reason is, right, two people are there with the same name. That's the reason this problem is coming. That's the reason compiler will give error message. Multiple declaration error. Try to understand. In one family with the same name, more than one person not allowed. In one family with the same name, more than one person not allowed. If at all there is an ambiguity. Definitely you will get the error message, multiple declaration error. So when kid 2 decided he want to keep both the kid name as Y, then definitely kid 2 partner, kid 2 wife will do dharna. How can you keep my son name as both the son name as Y? How can you keep both of my son name as Y? She will do dharna. So what I mean to say is, if you try to keep the same name for both the people, definitely your partner don't allow. Your family members also don't allow. When you try to keep same name for two people, your family members don't allow, which is nothing but a compiler error. Compiler will give error. When you try to keep the same variable twice, int A, compiler will give error message saying that multiple declaration error. This story will be taken by semantic analyzer. Semantic analyzer first responsibility, type match, type checking. Second responsibility, declaration is done or not. Third responsibility, multiple declarations. So careful. Okay, fine. I think that's okay. Now again I want to ask you one small line. Please help me. Who stored types in symbol table? Mostly who stored? I know very well all people are stored, it's okay. But I want to ask you, those types are stored by whom? In the symbol table, these types are stored by whom? Types. These types are stored by whom? In symbol table, these types are stored by whom? Who need types? Actually, all I can understand. Anyone can store. That's okay. If I want to say types are stored by whom? Who need types? Semantic. Whenever declaration is there, declaration means something related to type. Semantic analyzer will come and will store. Whenever declaration is done, declaration means data types only. So semantic analyzer will come and he will store because he want types. Semantic analyzer want types. So whenever declaration is there, immediately semantic analyzer will come because he want types. Declaration is related to types only. Semantic analyzer, see I written also. Semantic, right? Semantic stored. Semantic will store because the types are associated with the semantic analyzer. So when at any point of time, if you declare, right, declaration internally contain data types and all, immediately semantic analyzer will come and will say, it is my statement, I will store. Okay, fine. It is a my statement, I will store. It's fine. Not right. So I think X is stored, which X is stored in the first row, type is float. If at all local or global, that will also store in the memory location. In the memory location where memory created, that address also stored in one more column. One column is sequence number, one column is a variable name, one column is a variable type, one more column is scope of a variable, one more column is address. Address of a X address. X address what? In the memory, what is the X address? In the memory, what is the A address? All the things you will store. That's okay. Remember everyone, because of declaration contain data type. Data types are related to semantic analyzer because you have to do type checking and all. So semantic analyzer will store in the symbol table. Okay. Now observe. Everyone observe. Interesting answer. Everyone observe. Interesting answer. Let us assume. Very important one. Very important one. Let us assume declaration not there. Interesting answer. Let us assume declaration not there. Can you help me now? If declaration not there, you only say. If declaration not there, in the symbol table, nothing will store. Let us assume I written a program without declaration. Everyone understand. Let us assume no declaration. So symbol table is empty now. Carefully try to understand. If declaration is there, declaration means data type. Data types are related to semantic analyzer. Semantic analyzer will come and will store data types and all. That's okay. Let us assume no declaration. Means symbol table empty as of now. No declaration, symbol table is empty as of now. Now see what happened. What Lexical will do, see everyone. Because of lack of declaration, nothing there in the symbol table empty. Now see what Lexical analyzer is doing. Lexical analyzer will ask the X. Hello X, can you introduce yourself? Hello X, can you introduce yourself? What X is saying is, I am an identifier. Lexical analyzer is asking every person, hello X, can you introduce? X is saying that I am an identifier. Immediately, lexical analyzer will do like this one. If at all you are an identifier, you should be there in the symbol table. If at all you are an identifier, you should be there in the symbol table. So he will go and check. When he checking, nowhere X is there. Whenever he checking, nowhere X is there. Are you getting? Whenever no declaration in the symbol table, nothing there. No declaration means in the symbol table, nothing. Now, whenever lexical analyzer started doing tokenization, lexical analyzer will ask the X, hello X, can you introduce yourself? X said that I am an identifier. Whenever X will say I am an identifier, then lexical analyzer will go inside symbol table. He will check anywhere X or not. Because if it is identifier, it should be there in the symbol table. He will go inside the symbol table, he will verify. In the symbol table, he is not there. Can anyone help me? What lexical analyzer will do now? I want answer. X said that I am an identifier. Lexical analyzer will do like this one. If at all you are identifier, you should be there in the symbol table. Let me go and check. He will go and check. He got to know he is not there. Can anyone say what lexical analyzer will understand now? I want answer from all of you. Bro, I want answer from all of you. X said that I am an identifier. Whenever he said he is identifier, immediately lexical analyzer will go inside symbol table. He will check. If at all he is identifier, he should be there in the symbol table. Let me go and check. He verified. He got to know nowhere X there. Can anyone help me? What lexical analyzer will do? Make it fast. If you sit idle, you don't get anything. If you sit idle, you don't get anything. Class is so boring. Class is so boring. If you sit idle, you don't get anything. Can you help me? Can you help me? What it will do? So Mohit is saying that undeclared variable semantic error. Please remember, Mohit, please remember that work is done by semantic analyzer. I am talking lexical now. Now I am talking lexical. That work is done by the semantic. How can you say semantic work also here only? How can you say semantic work also here only? Lexical analyzer is asking, hello X introduce. X said that I am a identifier. Immediately lexical analyzer is saying that if at all you are identifier, you should be there in the symbol table. If at all you are identifier, you should be there in the symbol table. Let me go and check. He went and check. He got to know that. He went and check. He got to know that he is not there. Can you see, whenever it is not there, lexical analyzer will say to X, you are a liar or not? Lexical analyzer got to know, okay, he is saying he is identifier, he is not there in the symbol table. He is saying that he is identifier, he is not there in the symbol table. Lexical analyzer got to know that. Lexical analyzer got to know that it is not declared. Am I right or wrong? At this point of time, lexical analyzer got to know that. At this point of time, lexical analyzer got to know that he is not declared. Am I right or wrong? He said it is identifier. He will go and check in the symbol table. He is not there. Because of he is not there, lexical analyzer got to know that it is not declared. Yes or no? Lexical analyzer got to know that it is undeclared. Yes or no? He got to know it is undeclared. Yes or no? He got to know. He got to know it is undeclared. He got to know it is undeclared. But remember, he got to know it is undeclared. But one thing, that work is taken by whom? Undeclared variable, declared variable, that is done by whom? He got to know it is undeclared variable. But actually that work will be done by whom? Actually that work will be done by whom, yaar? But it is done by semantic, na? But it is done by semantic. Now see what he will do. He got to know, lexical got to know. Oh, if it is the identifier, it should be there in the symbol table. Let me go and check. He verified. He got to know that it is not there. Whenever it is not there, immediately lexical realized, oh, this is undeclared. It is undeclared. Actually, he want to write undeclared variable and all. But everyone having their work. They cannot interfere in others' work. That work is done by the semantic analyzer. He got to know because he is the first phase of the compiler. Many things he will see. Lexical analyzer is the first phase of the compiler. Many things he will see, but he don't react because for everything there is a one person waiting. Semantic will be taken care by that one. He got to know it is undeclared variable because of his the first phase of the compiler. He got to know, but it is not his work. What he will do is, listen, it is none of his work. See, he want token number. Remember, lexical analyzer want token number, but unfortunately, he got to know he is not there in the symbol table. If he is not there in the symbol table, he cannot give token number. He got to know it's an undeclared variable, but he don't say anything because for that purpose, one person is waiting. He will take care. But he want one token number. What he will do is he will store the X in the symbol table. You don't store the type. Someone is saying, does right, sir? One question: does the lexical? You will see afterwards. Yeah, you will see afterwards. It will confuse other people. It will confuse other people. You will see afterwards. You will see afterwards. So lexical got to know that it is an undeclared variable, but it is not his work. He will control somehow. But one thing, every identifier he have to give one token number. What he will do is he will store in the symbol table without type. See, without type he will store. He will store in the symbol table without type. He will give token number ID comma 1. He will give because if you don't know type, so type he will keep gap. His goal is not undeclared variable and all. That purpose some other person is waiting. He will do only his work. If at all he is already exists to, right, then he will give token number directly. If not exists to, he will store and he will give token number. If he exists to, he will give token number directly. If not exists to, he got to know undeclared variable, but it is not his work. He don't do that. He don't do that. He will pass that work. Later phases will take care. So his work only will do. If there, he will give token number directly. If not there, he will store it and he will give token number. In the similar way, A said that I am an identifier. Immediately lexical thought that if at all you are identifier, you should be there in the symbol table. He will verify. He is not there. Oh, it is also undeclared, but it is not my work. So later stages will take care. But I want this A in the symbol table, but unfortunately not there. So he will store A in the symbol table. Type he don't store anything. So token number he will give ID comma 2 because he have to give token number. He have to give token number. Next one, I think B also said that identifier he will go inside not there. So he will store it and he will give token number. Now it is a correct time to ask you. It is a correct time to ask you. Listen, it is a correct time to ask you. Who will store inside symbol table? Again, I'm asking you, who will store inside symbol table? Sometimes semantic or not? Who will store inside symbol table? Sometimes semantic or not? Sometimes lexical or not? That is the reason I'm saying to you, all pages can store. That is the reason I'm saying to you, all pages can store. If declaration is there, semantic will store. If declaration is not there, lexical will store. Are you getting? Bro, are you getting? If declaration is there, semantic will store. If declaration is not there, lexical will store. Yes, no. Right? I think now people got. Now all the people got. Now see what happened. Now all the people got. So declaration is there, semantic will store. Declaration is not there, lexical will store. See, even though lexical knows some problems, but because of it is not their work, they will control. They will control. They will do only their work. See, if everything done by first person only, what other pages will do? Even though you know, you have to bypass. See, most of the things Papa knows. But if at all he is a nice Papa, he have to forward something to kids also. In house, every problem Papa knows. Every problem Papa knows. If at all he is a nice Papa, he have to forward something to their family members also. Because everything you only doing, then what other people will do? You have to pass. Otherwise, it is a serious issue. In some families, Papa will kill himself. Because you don't pass. And a few things you do, main things you do, small thing give to mama, right? Some more small things, give to kids. Everything you cannot stop. If you hold on everything, serious problems will come. So declaration there, semantic will store. Declaration not there, lexical will store. So remember, lexical person want one token number. But if I want to give token number, he should be there in the symbol table. He is not there. He will store and he will give token number. He will store and he will give token number. Now see what happened. Some people are asking. Now see what happened. Very interesting. Very interesting. Now see this one. Whenever semantic analyzer is doing type checking, see the interesting answer. Whenever semantic analyzer doing type checking, now see the answer. Whenever semantic analyzer doing type checking, see ID1, I want to know what is type. ID1, I want to know what is the types. What is the answer? Symbol table, first row you go. As usual, when he started do type checking, right? ID1, I want to know ID1. This identifier type I want to know. So symbol table first row you go. If you go symbol table first row, there is no type. Whenever semantic analyzer is doing type checking, right? Symbol table first row I went. X is there, but type is not there. Then semantic analyzer got to know, oh, type is not there. Oh, it is undeclared variable. Like that, semantic analyzer will go. So you always remember, you have to pass any problem to the concerned person. Don't do everything by yourself. Don't do everything by yourself. Sometimes you know you want to do. If you do everything by yourself, why other people? So Lexical got to know it is undeclared, but he cannot do everything. So just he will do his work, he will bypass. So concerned person, see, this person is exactly meant for a type checking. This person is exactly meant for a type checking. When he is doing type checking, right, he want to know identifier one type he want to know. Symbol table first row he will go. In the first row X there, but type place gap is there. Oh, it is undeclared. Oh, it is undeclared. Same thing here. So whenever you will go to ID2, so ID2, what is the type of this person? Symbol table second row you will go, because see, identification number 2. Symbol table second row you will go, you will check. Second row, A there, but a type place gap there. Oh, it is also undeclared. So like that you will check. So remember, everyone having their work. Everyone having their work. Even though sometimes I know I may not say, because I feel that this is the work of students. Sometimes I know, but still I don't know. See, whenever we have a doubt solving group, EPT having a doubt solving group. Try to understand. EPT having a doubt solving group. If any student will post the doubt, sometimes I know answer, I want to give directly, but I don't give. I know answer, someone posted some doubt. I know answer, I don't give, because let them try. If I keep on helping every time, they don't grow. Right? If anyone asks me personally, I will simply say, can you post in the group? Can you post in the group? Can you post in the group and ask? Right? So when you post, right, 1 or 2 minutes answer may not come, right? After some time, someone will solve. Someone will say this answer, right? So everyone should do their work. So his goal is types. Type any problem, he will take care. Declaration any problem, he will take care. Type any problem, semantic will take care. Declaration any problem, semantic will take care. Multiple declaration, semantic will take care. So 3 points I am writing here. 3 points. Semantic will do 3 points. One, type checking. Semantic will do 3 works. 1, type checking. 2, declaration. 3, multiple declaration. Multiple declaration. So these are the 3 things. Okay, I think now people got it. Remember, depending upon the situation, right? Sometimes semantic will store, sometimes lexical will store, sometimes, right, syntax also will store. Remember, in the symbol table, anyone can store. Everyone having right. I feel everyone got it. I feel now everyone got it. Now let's go to remaining small issues are there. I will clear those also. Everything is clear. Now see here. Now see clear. So can you help me? Can you help me? I think if you see intermediate code generation, code optimization, target code generation, if you observe these three people, remember, if you observe these three people, intermediate code generation, code optimization, target code generation, if you observe clearly, remember everyone, purpose of compilation, conversion from high level to low level, purpose of compilation, conversion from high level to low level. Remember, purpose of compiler is conversion high level to low level. Remember, from here onwards the actual conversion will start. Remember, our goal is conversion only. Compiler purpose is conversion high level to low level. So here onwards conversion will start. So intermediate code generation onwards, conversion will start. See, your statement, right? Your statement first converted into here. Next, code optimization. Lastly, target code. See, lastly converted. Remember, our actual conversion will start from intermediate code. You may say that, sir, our goal is conversion high level to low level. Conversion will start from here. Then what you done before, sir? The actual conversion will start from intermediate code. Then what you done before? Remember everyone. Your compiler is not only converting. You have to verify also program is valid or not. Valid program, then only will convert. Don't convert directly. Valid program or not, verify. The program, whatever user written, is it valid or not, verify. If it is valid, then convert. See, remember, so conversion start from here. Before conversion, you are checking. Lexical will do introduction. So I'm writing here, see this one. Lexical will do introduction. Okay. Next one. After introduction is over, syntax will do physical checking. Program physically correct or not. Semantic will do logical checking. Meaning wise correct or not. Physically correct or not syntax. Meaningfully correct or not. Means logically correct or not semantic. If these three people are okay, means program syntactically, semantically correct. If these three things are done, program syntactically, semantically correct. In the program, no fault. Then you can go for conversion. Conversion is intermediate code generation. That is the conversion. Next one. After conversion is over, intermediate code generation, any unnecessary code is there. Do code optimization. Lastly, target code. First three steps are checking. Right? Last four steps are conversion. Last three steps are conversion. First three steps are checking. Now listen everyone. Our goal is high level to low level. Then what is this intermediate code? Remember everyone. Listen. Remember everyone. It is the road. Everyone remember. It is the road. In the road, you are on the left side. You want to go to right side. It is the road. You are on the left side of the road. You want to go right side. Assume that you are riding a car. You are on the left side of the road. You want to go to right side of the road. Then don't go directly. See, some people will go like this. You are there on the left side of the road. You want to go to right side. Some people, immediate turn they will take. Immediately they will go like this. So what you do is, don't do like that. Right? You are on the left side. You want to go right side. Don't go like this. Don't directly go to right side. First to left to middle you go. First to go left to middle. Then afterwards, middle to right you go. Then it is a better. So your goal is left to right, but don't go to left to right directly. First go to left to middle. Left to middle you go. After coming to middle to right you go. If you do that, it may be time consuming, but it don't spoil the code. Same thing here also. You have a high level code, you want low level. Then what you do is, You go to middle level, intermediate code. Go to middle level. So first to high level to intermediate code create. After intermediate code is came, lastly go to target code. Target code is low level. So what I mean to say is, first three people will verify program syntactically, semantically correct or not. If it is correct, then don't write directly low level. Please go to intermediate level first. Intermediate code generation will create intermediate code. So that no damage will be there. If you do suddenly high level to low level, problems will come. High level to low level, problems will come, remember. So high level to middle level go first. Intermediate code generate first. After getting intermediate, then go to target code. Right? Okay, that is okay. Now some people are asking, first three steps are checking, right? Next three steps are conversion. Remember everyone, these first three steps are known as front end of the compiler. This is called front end of the compiler. First three steps are known as front end of the compiler. Right? Next one, last two people are known as back end of the compiler. Back end means last goal. It's the back end of the compiler. Back end means target. So this is called middle end of the compiler. Remember, it is not a part of the front end. It is not a part of the back end. Right? It is the middle end of the compiler. So it is the front end of the compiler. It is the back end of the compiler. It is the middle end of the compiler. So if you want to go to right high level to low level, please don't go directly. First go to middle. Middle to right, front to middle to back. So they will ask you in the examination, who are the part of the front end? Lexical, syntax, semantic. Who are the part of the back end? Code optimization, target code generation. What about intermediate code? What about intermediate code? Is the middle end of the compiler. Is the middle end of the compiler. Just 1 minute. Yeah. So that is the reason I got a little doubt. Sorry for this. Sorry, I forgotten. Yeah. So this is the case. Careful, everyone. I'm really sorry. These four people are front end of the compiler. This person is back end of the compiler. This person is back end of the compiler. This is middle end of the compiler. Yeah, just can you once again take? Can you take once again? I'm really sorry. Just I added one thing extra. So lexical to intermediate code, front end of the compiler. Lexical to intermediate, front end of the compiler. Right? Only code optimization, middle end of the compiler. Target code generation, back end of the compiler. So careful. It is right? It is the middle end of the compiler. Target code generation. Right? Please take care. Do small change. Do small change. Remember, they will ask you who are part of front end, lexical to intermediate code. Who are part of middle end, code optimization. Who are part of target code generation. So backend. Only target code is backend. Code optimization is middle end. First four people are front end. right? Be careful. So these I think maybe from my cache memory they went little bit. They went out little bit from my cache memory, right? Okay, fine. Now perfect. Now perfect. So remember all these things. Remember all these things. Okay. Now I will ask you one question. See this one. Now I will ask you one question. Please take care, everyone. Now I will ask you one question. Careful, everyone. Front end, back end, and middle end. Now I will ask you one question. Please see this. Can I do code optimization every time? Can I do code optimization every time? Is it possible every time? Is optimization possible every time? Can I do code optimization every time? Yes, no. Can I do code optimization every time? Sometimes may not be possible, right? That is the reason. That is the reason. This code optimization phase, this one is the optional phase. It may be there. See, in some compiler, it may be there, may not be there. Special phase may not be there. Special phase may not be there. See, while writing intermediate code itself, if you are careful, code optimization not needed. While writing intermediate code itself, if you are careful, you no need to write code optimization. So that is the reason it is the optional phase of the compiler. They may ask you in the examination, who is optional phase of the compiler? So you can simply say code optimization. That is the reason they kept the middle end of the compiler. It's the middle end of the compiler. In some compiler, there is no middle end. In some compiler, there is no middle end. Now, last time I want to ask you, front end means lexical to intermediate code generation. Target code only back end. Code optimization is optional phase, which is also middle end of the compiler. Now one important thing is coming. So if anyone having one or two doubts also, you can ask me. I said all the things which are required to you. Next to total these 6 people will be divided into 3 parts: front end, back end, middle end. Middle end, right? Code optimization, it is the optional phase, because while writing intermediate code itself, if you are careful, there is no requirement of code optimization. When you do in the intermediate code, little bit loose, you are not done properly. If you have doubt, intermediate code writing, if you think that you done unnecessarily some steps extra, then I have to go for code optimization. Suppose intermediate code itself, if I am strict, I am not done anything wrong, code optimization is not needed, then it's going to be optional. In some compiler it may be there, in some compiler it may not be there. Code optimization phase is the optional phase. Back end contain only target code. Front end contain lexical to intermediate code. So be careful. Now I will ask you one small thing. Please give answer. Your goal is high level to low level, okay. Your goal is high level to low level, okay, right? That is your goal, high level to low level. If you do directly, problems may come. First go high level to middle level. High level to middle level you go. Middle level to target you go, then problem becomes easy. So that is the reason, right? That is the reason Rome is not built in single day. Rome is not built in single day. You have to go slowly. If you run, problems will come. I want high level. I have high level. I want to go to low level. If you do directly, problems will come. You are on the left side of the road. You want to go to right side. If you go directly, problem will come. Accidents will happen on the road because of this reason only. Why accidents will happen is because of this reason only. There is one person on the left side. He want to go to right side. He will go straight. You cannot go like this. You are on the left side of the road, you want to go to right side, don't go straight, don't do directly. Don't do directly 90 degrees like that. Don't do this. Don't do directly 180 degrees, right? It's 180 degrees. Don't do directly like this. Don't do directly like this one. You have to go like this. It may be some time consuming. You have to go like this. Same way here also. High level to low level, high level to middle level you go, middle level to lastly low level. If you do that, there is no damage to anything. So in any one life, any damage happened, the reason is this only. They tried high level to low level. In any human being life, any damage happened, this is the reason for that. High level to low level, they tried. Try to go high level to middle level first, middle level to low level. If you do that, there is no damage. So they are following the same model. They are following the same model. But remember, target code contain backend. Target code means backend. So try to understand this. Now see the interesting story. Careful everyone. See the interesting story. Everyone listen. Everyone listen. This is going to be very important one. This is going to be very important one. Can everyone see? Can everyone see? If I compile C program, see this one. If I compile C program, right, it will done from here to here. C compilation, if I do, it will done from starting to ending. When you do C compilation, lexical, syntax, semantic, intermediate code generation, code optimization, target code, right? So it will be done from top to bottom. But if you do Java compilation, listen, if you do Java compilation, it will do until here only. Java compilation will do half compilation. Java don't do full compilation. Java will do half compilation. Remember, Java program, if you compile, you don't get the low level code. You don't get the low level code. You will get the byte code, which is also called as intermediate code. You will get the intermediate code. Java compilation until here only. You will get the byte code, which is also called intermediate code. Which is also called intermediate code. But if you do the C compilation, you will get the, right, you will get the, not the intermediate code. You will get the lastly low level language. It is a C compilation. Different compiler, different models. If you do C compilation, top to bottom, it will be done. Top to bottom. If you stop in the middle, only Java compilation. If you do from top to bottom, C compiler. So remember, C compiler will give machine language, machine dependent language. C compiler will give, after compilation, machine dependent code. If you see the Java compilation, it will give byte code or intermediate code. It is a machine independent code. Machine independent code. Some people are asking, what is the meaning of machine dependent code? What is the meaning of machine independent code? Remember the answer C. After C compilation is over, whatever you will get, machine instructions you will get. What are those? Add. These are the machine instructions. Mul. These are the machine instruction. Increment, store, move, div. So like that. So remember C compilation is over. Lastly, you will get the low level language, which is nothing but a machine dependent code. But when you go to Java compilation, only half compilation, you will get the intermediate code, machine independent code. Remember, in this one there is no instruction. Some temporary variables are there. Intermediate code, some intermediate variables are there. T1 is equal to A plus B, something like this. T1 is equal to this. This is not a machine code. T1 is equal to A plus B. T2 is equal to T1 plus something. T1 into C, something like that. So now it is the correct time to ask you, C compiler, Java compiler. Can you say which will take more compilation time? C compiler, Java compiler, which will take more compilation time? C compiler, Java compiler, which will take more compilation time? C compiler, Java compiler, which will take more compilation time? Who will take more compilation time? C, because total C, full compilation you are doing. Full compilation you are doing. In the C compiler, you are doing full compilation. All 6 pages. All 6 pages you are doing. If you do 6 pages, right, you will get the machine dependent code. That's okay, but it will take more time. C compilation, right? C compilation will take more time because you are doing top to bottom. Java compilation will take less time because you are doing top to middle. You are doing top to middle only you are doing. The advantage with the Java compilation is, right, it is a machine independent code, which is also called as portability. Which is also called as a portability. See, machine independent code. Independent means portability. Independent means portability. It is a machine independent code. Means what is the meaning? Running can be done in any machine. Because of already you have a machine independent code, in any machine you can run. Java code after compilation is over, you will get the byte code, which is also machine independent code. Irrespective of a machine, it will run. In any machine you can run. After Java compilation is over, whatever you have, that code you can run in any machine. Machine independent code, which is also called portability. But C compilation is over, whatever code you got, machine dependent code means in which machine you compiled, in the same machine you have to run. That is called machine dependent code. C compilation, one drawback. C compilation, one drawback. C compilation time is more because you are doing top to bottom. And one more drawback, machine dependent code you will get. In which machine you compile, in the same machine you have to run. But Java compilation, if you see, first advantage, compilation time less. One more advantage, machine independent code you will get. That code can be run in any machine. Portability you can achieve. You can achieve portability. Okay. I think this also people got it. Now listen, it is a correct time to ask you. It is a correct time to ask you. Processor will understand. Processor will understand high level language or middle level language or low level. What processor will understand? Processor will understand what language? Processor will understand what language? Processor understand which language? High level, low level, or middle level? Low level. Processor will understand low level. I think, see, after C compilation is over, you got low level. If you give to the processor, it will run fast. If you give to processor, right, it will run. Directly it will run. So C compilation is over. You will get the low level code. That code given to processor, it will run it. It will run it. Now let's go to right. Listen, let's go to Java. If at all Java compilation is done, you got the intermediate code. Now listen, you got the intermediate code. This intermediate code, if you run, see this one. This intermediate code, if you run, if you give this code to processor cannot understand. What processor will do is, I given to processor. What processor will do is, it should do first. It should do, right? I think middle level to low level first. First it has to convert. Middle level to, you are given this code to CPU. What CPU have to do is, first it has to convert to low level. After low level, it will run. Now, it is a correct time to ask you, C program running, Java program running, which is faster? C program running, Java program running, which is faster? I'm talking about running. C program running, Java program running, which is faster? C program faster. It is faster because you are directly giving low level. As soon as you will take low level, if I give low level to processor, directly run, it is faster. It is slow. Comparing C language, it is slow. Comparing C language, it is slow. Right? Fine. So remember, Java is not full compiled code, right? Fully compiled. It is a half compiled, half cooked. It is a half cooked food. Java compilation is, Java language is half cooked. Means in the total compilation, half only will do. The advantage is portability you are getting. The advantage is portability. On any machine you can run. See, when you say advantage, there is a drawback also. Advantage is portability. In any machine you can run. But what is the drawback? What is the drawback? The drawback is, right, I think running time little more. Running time little more. But if you go to the C compilation, compilation time more okay, but you will get the low level language, which is going to be machine dependent, which is going to be, right, platform dependent. C programming, C compilation will do lastly platform dependent. Machine dependent code means platform dependent. In that platform only you can run. The advantage is, right, because of already there in the low level, advantage is going to be program going to be faster. Running time is less. C program running is less time. Java program running is little bit more time. Comparing C, Java program running is little bit more time. Now some people are asking, very interesting. Full compilation C program. Careful everyone. Full compilation C program. Half compilation Java program. There are some languages, no compilation at all, directly running. Those are called interpreted languages. Those are called as interpreted languages. So, right, if you see the Python language, it is an interpreted language. No compilation, directly running. Right? Python is an interpreted language. Are you getting? Python is an interpreted language. No compilation, directly running. So can you help me now? If I give to the processor high level language, if I give to the processor low level language, if I give to the processor, right, middle language, which one faster? If I give to the processor high level language, if I give to the processor low level language, if I give to the processor middle language, which one faster? If I give processor high level, low level, middle level, which one faster? Low level? Low level if you give to processor faster. So C language faster. C language faster. If you give to the processor, intermediate code like Java, it will take a little more time. If you give to the processor high level language like Python, in Python there is no compilation, directly running. Python is an interpreted languages. You are given high level directly, no compilation at all, directly running. It is an interpreted language. What is the meaning? High level you are given to processor and you are saying that run. Then what that processor will do is it has to convert all the things into high level to low level first. Then it has to run. So, right, Python program running will take more time. Right? So I am writing some example. Interpreted language means no conversion. Interpreted language means no compilation, directly running. So let me write now. C program. Full compilation. Two. It's a full compilation, one thing. You will get the low level. Language. Full compilation is low level. Faster. Java program. Half compilation. Two. You will get the intermediate code. 3. It is a middle. So next one, Python. It's an interpreted language, no compilation, directly running. Means what is the meaning? You are given directly high-level language to processor. Processor have to convert now. Directly running. But high-level language directly running means processor, it will take a lot of time to understand. So it will take more time. So that is the reason. So Python is called interpreted language. It is an interpreted language, no compilation. It is an interpreted language. The only drawback with the Python is it is slow. The only drawback with the Python is it is slow. It is slow. The only drawback with the Python is it is slow. It is if anyone asks why Python is slow, you would just say interpreted language. You just say it is an interpreted language. Why C program is faster, right? You can simply say full compilation. It will give low-level language. Low-level language running is faster. CPU will understand low level. CPU understand low level. So what is the advantage with the Java? What is the advantage? Platform independent. In one platform you can compile. In another platform you can run. Every language having its own advantage. Java advantage is platform independent. C programming advantage, it is a faster. Python programming language advantage, no compilation, directly running. Interpreter will run directly, no compilation. So because of you are running directly high level, so I think understanding every line will take a lot of time. So it is slow. It is slow. So remember this, which is part of the front end, lexical to intermediate, which is part of back end target code. What about code optimization? It is the middle end of the compiler. Okay, fine. Until now, you are really okay. Let me know if anyone having any doubt. Any objections are there? Let me know. Someone is saying, sir, if we write a code in C, then will it get automatically optimized? Of course, code optimization is done. See, at the end of the day, everyone will optimize. Hit to try to understand, at the end of the day, everyone will optimize. At the end of the day, right, everyone will optimize. So in the code optimization phase, they will optimize. Every code will optimize. Internal, every language having their own techniques internally. Not manually, sir. See, manual optimization done by the programmer. Manual optimization done by the programmer. Programmer have to optimize. If you don't optimize, compiler will optimize. As a programmer, you can do optimize. If you don't optimize, right, code optimize. See, if you see the compilation, there is a one phase, code optimization. There they will optimize. You do optimization. If you don't do, compiler will do optimization. That's what I'm saying. As a user, you optimize. If you don't optimize, compiler will optimize. Some people are asking, sir, example, something like this. Listen, something like this one. Everyone try to understand something like this. Careful. A is equal to 5 into 1. You written A is equal to 5 into 1. So if you have to write A is equal to 5, why you unnecessarily written one multiplication? A is equal to 5 into 1 means A is equal to 5. Finally want to say A is equal to 5. Then why you written 5 into 1? So if you write unfortunately 5 into 1, right, what compiler will do is while compilation is going on, he will replace A is equal to 5. He will replace A is equal to 5. Fine, it's okay. As a user, you don't write unnecessary thing. If you write, compiler will optimize. If you write, compiler will optimize. Fine, can I move to next? Can I move to next? Bro, can I move to next? Check anyone having any small doubt also, you can ask me. Sir, I have this doubt. You ask me, I will help. Mohit, do you have any doubt? Some people are asking, what is the meaning of interpreted language? No compilation, directly running. What is interpreted language? No compilation, directly running. Some people are asking, how can you run directly? That is the issue. You cannot run directly, but you are running. So you have to convert internally. Processor itself is trying to convert. Means you are wasting time. If anyone try to do directly, there is a procedure for everything. You will try directly, problems will come. It may look like no compilation directly running, but whatever is going on in the compilation directly, previously compiler is doing, now processor is doing. If you do directly running, compiler work also, processor only doing. CPU time you are wasting. What is the meaning of interpreted language? No compilation, directly running. How he will run directly? Line by line he will take, he will convert, and he will run it. Line by line he will take, he will compile it himself. Processor itself will compile it itself. He will understand what is the meaning, and he will run the story. So if you read line by line, and if you do conversion, and if you run, that is called interpreted language. Will compiler use preprocessor? So try to understand everyone. Compilation will start from preprocessor or lexical. Compilation will start from preprocessor or lexical. Compilation will start from preprocessor or lexical. Lexical, compiler and preprocessor, no relation. Compilation, preprocessor, no relation. Compiler will start from here. Right? Remember, before compilation, something there. See, before compilation, something there. Here, something there. It is not part of the compilation. Before compilation, something. After compilation, also something. What compiler? High level to low level. Before compilation, what is there? There is a preprocessor. After compilation, what is there? There is a assembler, there is a linker, there is a loader. So for user convenience, actually, let me say this also. Actually, when you say compile, only it should happen. Compiler means actually this only will happen. For user convenience, they may be doing some extra work. See, this is not part of the compiler. Remember, this is also not part of compiler. This is also not part of the compiler. Compiler means this only. For user convenience, right? To save the user time, maybe when you say compile, right, it will start from here. Actual compilation, this only. This is only compilation. For user convenience, they may be doing some extra services. For user convenience, but compiler means lexical onwards it will start. Target code it end. Before compilation, for user convenience, some extra work may be done. After compilation, for user convenience, some extra work. But remember, they are the extra work. Compilation means high level to low level. Thank you so much for asking. It is a very beautiful question. Okay, fine. You are absolutely fine. Until now, absolutely everyone is fine. Now understand. Very one more interesting thing is there. I will say that also with this story over. Right? One more interesting thing is there. Can you see this one? One more interesting thing. One more interesting thing. Lexical analyzer, syntax analyzer, careful, semantic analyzer, intermediate code generation, code optimization, target code generator. Listen this point also. Lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generation, code optimization, target code generation. So these are the 6 phases of the compiler. Okay. These are 6 phases of the compiler. I know this very well. You also know. And everyone know compiler is a software. Compiler is a software. It means it is a program. It is approximately, right, 1 crore lines of code. Maybe more also. No one will ask you. Compiler is a very big program. It may be 1 crore lines of code. Assume. It may be 1 crore lines of code. It's a very big program. Now observe clearly. Observe clearly. Observe clearly. There is a program. See this. There is a program xyz.c. There is a program xyz.c. Everyone understand. Compiler is a 1 crore lines of code. I can say very big program. It's a very big program. Compiler is a very big program. Remember, compiler is nothing but set of rules. Compiler is nothing but conditions. Compiler is nothing but 1 crore. Listen, 1 crore conditions are there. 1 crore rules. Compiler is nothing but set of rules. Everything is rule only. Now see what happened. On xyz.c, when you say compile, when you say on xyz.c, when you say compile, then what happened is xyz.c on these 1 crore lines, these 1 crore conditions are applying. xyz.c program, when you say compile, then what happened is on xyz.c 1 crore rules you are applying. So remember, this program also there in the main memory. This program also there in the main memory, because compiler also a program. So this 1 crore lines of code also there in the main memory. This your program anyhow in the main memory. When you say compile, right? So when you say compile on your program, these 1 crore lines are running. So when you say these 1 crore lines are running, so these 1 crore lines should also be there in the main memory. What I mean to say is, compilation is going means these 1 crore lines of program is there in the main memory. On the main memory, these 1 crore lines of, right, these many conditions are applied on your code. So program also there in the main memory, that compiler code also there in the main memory. Let us assume that main memory is very small. These 1 crore lines are not possible to come inside. So I think some people may be not able to understand. Now I am repeating once again. Your program is compiling means these 1 crore lines of code is running on your program. This 1 crore lines of program is running means these 1 crore lines of code is there in the main memory. So your program is compiling means these 1 crore lines of code is came to inside main memory. But let us assume that main memory is very small. This entire 1 crore lines cannot come inside main memory. So what I mean to say indirectly, directly, try to understand. See this one. If total compilation, if total compilation done in multiple passes, if total compilation is done in multiple passes, That story is called a multi-pass compiler. If you think that you have main memory very small, if you think you have main memory very small, in the small main memory, these 1 crore lines I cannot keep. Then what you do is, don't do compilation in one pass. Do compilation in multiple passes. What is the meaning? I may do first front end. I may do first front end. On my program, when I say first compile, only front end will come. Now on that front end, if I do code optimization, I will get middle end. On that middle end, if I do back end, then I will get the finally target code. What I mean to say is, if I say compile, these 1 crore lines of code should go to inside main memory. But main memory size is very small. These 1 crore lines cannot accommodate. Then what you do is, first to do only this part. Only this will go to main memory. Right? It will go to main memory on your program. Only these 4 people are working. 4 people done. You got the front end. On that front end, apply code optimization. You will get the middle end. On the middle end, you apply the target code. Then finally, you will get the low-level language. So, if total compilation is done in multiple passes, that is called multi-pass compiler. That is called multi-pass compiler. Some people are asking, sir, when I will go for this multi-pass compiler, when I will go? If less memory, right? If main memory less. If main memory less, then go for multi-pass compiler. Some people are asking, if main memory less, then go to multi-pass compiler, it's okay. But what is the drawback? More time. Right? See, 3 times coming, 3 times going. First 4 people will go. You will get the front end, take the front end and come back. Now on the front end, do middle end again. Then you will get the right middle end part. Now on that middle end, apply target code. So many times coming to main memory and going back again coming to main memory, going. So many times you are doing context switching. So more time. The drawback with this one is more time. It is a drawback. Multi-pass compiler, it is a drawback. Advantage. If main memory less, it is an advantage. Total compilation at a time. Single pass. Total compilation in the multiple passes. Then multi-pass compiler. Multi-pass compiler advantage. Less memory also you can manage. Drawback, right? More time. Let's see this one. Total compilation in one pass only. All 6 people will go. Do compilation. Come back. That is called single pass. Single pass compiler. Single pass compiler. It is a multi-pass compiler. It is a single pass compiler. Single pass compiler. What is the advantage? Less time. One time going, one time coming. All 6 people will go one time. They will do work and come back. Less time. So because of you are going one time, more memory required. Drawback. More memory. Right? More memory. Perfect. I think we done many things here. So every point I covered. I didn't skip one point also. Yeah, Prasoon, you can ping me. You can WhatsApp me. Prasoon, you can WhatsApp me. This is a WhatsApp number. Just you WhatsApp me. I will help you. right? Just WhatsApp me, I will help you. Yeah, some people are saying that. Some people are saying in which language that 1 crore will be written. It's after all program. Na? Kittu, it's a program, right? Compiler is a program. That program can be written in any language. Compiler is a program. Software, na? Software can be written in any language. Remember, compiler means software, which is nothing but rules. Rules can be written in any language. So suppose assume that I want to write compiler. Now whichever is a modern language, in that language I will write. Whichever is a modern language, I will follow it. Remember, compiler is a software. Software can be written in any language. Fine. Right? People are thinking that C compiler written in C language. No. C compiler means C language rules. C language rules can be written in any language. C language rules can be written in any language. Java compiler not written in Java language. It can be written in any language. Java compiler means what? Java language rules. Java language rules can be written in any language, whichever language you feel comfortable. In that language you write. But Java rules you are writing. So it is a Java compiler. I can write Java compiler in Python language. Java compiler means Java rules. Using Python I can write. Java compiler written in Python language. It's okay. It's okay. Fine. It's okay. Remember, C compiler means C language rules, not C language. C compiler means C language rules. Can be written in any language. Fine. Can we stop? Arey, Mohit, are you there? Mohit, are you there? Mohit, are you there? So if anyone is not joined, if you serious about GATE examination, if you are not joined, 80% offer is going on. You can join happily. 80% offer going on. You can join happily. You can use the code EPT 595 ARJ. You can use this code. You will get the 80% discount. Fine. Any batch you can join. You can join regular, you can join crash course, you can join RIC, you can join test series, you can join foundation course. Anything you can join. Fine. So I'm stopping now. Thanks for everyone. Thanks for attending the class. Thanks for attending the class. I want to see all of you next year, right, in this toppers list. Next year in toppers list, I want to see your name. Next year toppers list, I want to see all of your names. So I am recently in third year. Which batch is suitable? Third year. Yeah, you can go for. So you can WhatsApp me. I may help you. You can WhatsApp me. I may help you. This is the WhatsApp number. I may help you. This is the WhatsApp number. We both will talk and I will discuss, because I have to know your details. I want to know what is your clear thing. Means in which semester you are, how many subjects you completed. All the things I have to know. Just this is the WhatsApp number. You ping me. I will help you. We both will discuss. Whichever is suitable, I will help you. So I want to crack 2026, so it will help for future. So if you want 2026 only, you can go for this. Crash course you can take. 2026, you can take crash course. Only 2026 crash course. If you have mind, if in your mind 2027 also, you can go for foundation course. Right? Crash course. If at all 2026, go to crash course. 2027, go to foundation course. If you don't know which one you have to do, go for regular course. Go for regular course. It's up to you. 26 crash course, 27 foundation course. Dilemma is there, go for regular course. Right? Fine. And you can, anyhow, you can talk to me and I will definitely discuss with you. Yeah. So I think good night. Good night, everyone. Good night, everyone. Prasoon, you also can ping me. I will help you. Prasoon, you also can ping me. I will help you. Yeah. Chalo then. Bye. Bye, everyone.